Hi there. What we're going to be looking at today, now that Bob's finished on his guitar, is mechanics, and we're going to be looking at variable acceleration, which gets a little bit more interesting, and it starts to bring differentiation and integration into a real practical sphere. So good stuff to do. We did it initially right at the end of the first lockdown, so different ones of you will have different ideas of how much of this you can remember, and for some of you it may be a little newish, but it's all good stuff. So as a result, what we're going to do is I'm going to ask you to do all of the mathsgenie questions on this, but we're going to do certainly I reckon about 4 of them now I will do with you, and then the rest of you for you to have a look at, and let us know how you get on. Right, so when we're looking at variable acceleration, we've got 3 things we need to think about. We've got distance, and in order to remember what to do, think about the unit. So the distance is in meters. We've got velocity, and that, actually I should have said displacement instead of distance, and velocity is meters divided by time, or seconds. And last of all, we've got acceleration, which is when you've divided by time and then you've divided by time again, meters per second. Now that tells us which way we go in terms of differentiation. It's because we're continually dividing by time that if we differentiate by t, we can move from displacement through velocity to acceleration, and thereby, if we do the inverse of that, we can integrate to undivide the time, if you like, back up through acceleration, velocity and distance. So we want to know the velocity in terms of t, and we've been told the acceleration, so we need to integrate. So pause the video and have a go at doing that if you can. So telling in terms of saying what it is we're going to do, we should write v with the long S. I always want to call it a sigma. I'm not quite sure if I'm allowed to call it a sigma or not, but anyway, and then we've got the expression for the acceleration, and that needs to be differentiated by t. So now that's what I'm going to do, and I'm going to say, right, v is going to be, the t is going to go up to t squared, and we divide by 2, and the constant, that goes up by 1, because that is actually 8t to the power 0 in a way, isn't it? Because that would give you 1. That goes up to t to the power 1. And because when you are differentiating, any constants get dropped, we have to acknowledge the fact that there may be a constant there. So that is v in terms of t initially, but then we are told that the velocity when t is equal to 0 is 6. So for that reason, I'm going to say that when v is 6, I'm going to just tidy this up a bit. That'll be 2t squared, won't it, minus 8t plus c. If t is equal to 0, then that will become 0, doesn't it? C must equal 6, and therefore we can say that v equals 2t squared, take 8t plus 6. The second part of this question, have a think about this. Find the distance between the points when the particle is instantaneously at rest. So we need to know the 2 points when it's not moving. Therefore it has no velocity. So the velocity equals 0. So 2t squared take 8t plus 6 is equal to 0. Just need to solve that. I can divide everything by 2 to say 2 squared take 4t plus 3 equals 0. And then factorise to solve that. 3 times 1 is 3 and 3 add 1 is 4. So t take 3 and t take 1 equals 0. So therefore t equals 1 and t equals 3. So we need the distance between those 2 points. In order to get that distance, we're going to need to integrate the velocity first of all. So let's do that over here. So what have we got? We've got velocity. So I'm going to say the distance, which is normally called s, is going to be equal to, what is our velocity? It is 2t squared take 8t plus 6, and that needs to be differentiated by t. Let's do that then. So s is going to be, we up the power by 1 and then we divide by the new power, so the 2 is divided by 3. We up the power by 1 from 1 to 2 and we divide by 2. We up the power by 1 from 0 to t, and then we say, I know I'm going to need a constant in there. But I could have written here, I want it between points 3 and 1. So I put a square bracket around this and say 3 and 1. And then what I'm going to do is I'm going to work out, I'm going to put t equals 3 in here, 2/3 3 to the power 3, take 8 over 2 is 4, so I'll put 4 times 3 squared plus 6 times 3 plus c, and then we're going to be taking away all of these things with t as 1. Now that's a little bit easier because 1 cubed is 1, isn't it? So it's just going to be 2/3 take 4 plus 6, and we've got the plus c. Now at this point, whenever you're finding the difference between two parts, the c constants will disappear because I've got plus it there and I take plus it there, so I don't have to worry about those. If I work all of this out, I've got that's 27 divided by 3 is 9 times 2 is 18. 3 squared is, you can just chuck it in your calculator, 3 squared is 9 times 4 is 36. 6 3s are 18, so we've got that, and we're going to be taking away 2/3 take 4 plus 6, so that is 6 and 2/3 take 4 is 2 and 2/3, and we're forgetting about the c's because they're not going to exist anymore. And you may well have spotted that this is giving us 0 take 2 and 2/3, which is negative 2 and 2/3, but the distance between them isn't the displacement, it's just the distance, so therefore it is going to be 2 and 2/3, or you might have 8 over 3 meters. Right, here's our second problem. Take your time, write it down, pause it, have a go. We've got 2 different formulas for the acceleration, because up until for the first 3 seconds, it's accelerating according to one function and another one after 3 seconds. So, first of all, finding the speed of p. Well, if we consider that when we go from acceleration to velocity, it goes distance, velocity, acceleration, doesn't it? So we are integrating when we go up there. So if a equals 4t minus t squared, then velocity is going to equal that 4t take t 4t take t squared differentiated by t. So if we do that, we can say that that is going to be, we do our t up to squared, our 4 divided by the 2, and then take t, the t goes up to 3, and we divide by 3, so that's a third of t cubed, and then we're going to have our plus c as well. But we are told that when t is 0, p is at rest, so it's got 0 velocity. So if when time is 0, if all of this is going to equal 0, then c must be equal to 0. So c equals 0. We can say the velocity is going to be 2t squared, because 4 over 2 is 2, minus 1/3 t cubed. And if we want to know the velocity at time is equal to 3, we just need to substitute 3 in there, like that, and that's going to give us 2 times 9 is 18, take 3 cubed is 27, divided by 3 is 9, so 18 take 9 equals 9 meters per second, and that's part A done. Coming on to part B, we need to differentiate. We're saying A is equal to 27 t to the minus 2, always put it into multiplied format, and then we're going to integrate that. Our velocity is going to be 27 t to the negative 2 differentiated by t. So if we get some space here, the t goes up from negative 2 to negative 1, so be careful there, and we divide by negative 1. When you divide by 1, it's just going to be negative 27, isn't it? But we are also going to have our plus c. Now, how do we work out the c? Well, we know what the velocity is at time 3 seconds, because it's up to that and equal, and this says from all the time more than. Well, that means the tiniest amount more than 3.000. So effectively at 3 seconds we can assume that the velocity is 9 meters per second, because it hasn't had any time to get faster yet. So we can say 9 equals minus 27 t to the negative 1, might be easier to put that underneath here, divide by t plus c, time t equals 3, therefore we're looking at 9 equals negative 27 over 3 plus c, so that means 9 equals negative 9 plus c, add 9 to both sides, c equals 18. So I'm going to move over here now and put that 18 back into here. So v equals 18 is my constant, take 27 over t. When t equals 6, that means it's going to be 18 take 27 over 6. Whack that into your calculator if you can't be bothered to do it normally, and you should get 13.5 meters per second. We've done questions 1 and 3 from mathsgenie's sheet, so it may be time for a segment of chocolate orange to help us out with question 5. You may see a bit of a pattern developing here, so pause the video and give it a go. It wants to know the acceleration. So acceleration is meters per second, so you differentiate to go from velocity to acceleration, which is easier. It means we don't need to, they haven't given us any information about any particular moment when anything's happening. And that's because we do not need it when we're differentiating it. So acceleration is going to be dv by dt, which is going to equal, we drop the power by 1, so when it's just t's, we just drop the t. we drop the we multiply by the power, and we drop it by 1. So that'll give us minus 4t. And they want to know the time at which, or we want to know the time at which the acceleration is 0. So we just need to say that equals 0. Add 4t to both sides. Divide by 4. And that is, it's 1.5, isn't it? 1.5 seconds. The acceleration is 0. That's all for that one. Just one more question to go, folks, which is question 9. So pause the video, have a really good look at this, and then give it a go. Okay, here's the last question. A little bit of advice I'll give you before you start is make a little sketch of what's happening, especially well, for the second part, certainly, to visualize what's going on. Right, so you should have paused it and had your whole go by now. So the times when p is instantly at rest, that's going to be when the velocity is equal to 0. And we are told we've got displacement, haven't we? Then we've got velocity, then we've got acceleration. And you differentiate as you go from displacement through velocity to acceleration. Now we want velocity because we want it when it's not moving, so we want v equals 0. So we're going to be differentiating this. So the v is going to equal dx by dt, which is going to be 3 times 2 is 6, t drop the power by 1 to t squared. 18 times 2 is 36, drop the power by 1 to t, and then the 48t just becomes a constant of plus 48. And then we want to know when this is equal to 0, so let's just write equals 0 at the end. If I divide everything by 6, we get a simpler quadratic, and then if I factorize that badger, we've got 4 2's are 8, aren't they? So t minus 4 and t minus 2, so times 2 seconds and 4 seconds. So that's the first part done. Now we want to know the total distance travelled in the first 5 seconds. At this point, I'm going to go back and start thinking about what's happened. A particle P travels along a straight line through a point O. So let's put a straight line on, let's put a point O in there. So that at a time t seconds after passing through O, its displacement is x meters. So at 0 seconds, it's going to be there, isn't it? And it's getting positive, let's call that going to the right. So it's going to be going to the right until it stops, isn't it? So once it's stopped, that's because the acceleration is taking it back the other way. So if we've got 2 seconds, that happens, and then it's going to be going back the other way, maybe that far or something, 4 seconds, and then that's going to stop and it's going to go back again for the 5th second. So thinking about what's happened there, the displacement is going to go up, then it's going to go down, and then it's going to go up or get closer to, we're not exactly sure. We need to think about that as we do it. So now I'm going to, having said we need to think about it, I'm going to forget about it, and I'm just going to find out what the displacement is at the important times. I know the displacement at time equals 0 is 0. So the next important time, so displacement at t equals 0 equals 0 meters. When it's 2 meters, we need to pop it into the displacement thing. So t equals 2, x is going to be 2, and I would just write it out again and put 2 in instead of t, like that. And what, instead of t, like that. And then you can pop 2 into the calculator so that what you get should look something like that. And that's your working to write down and your distance. So that's 40 meters. Then repeat the process for 4 seconds and we get 32 meters. Oh, I was expecting a negative. Obviously it hasn't come back as far as I thought it would do. And then again for 5, and that gives me 40 meters again for 5 seconds. So if I review my model, actually the zeros there, it's going to be like 40 meters to t is 2 seconds, and then we're just going back about to there, aren't we, after 4 seconds, and that's now saying 32 meters, and then to in the last second we're going all the way back to where we'd come from, so getting us to 40. So we've actually got 40 meters. From 40 back to 32 is 8, from 32 back to 40 is 8 again. So we've got 40 plus 8 equals 56 meters. And that's it. That's all the examples I'm going to show you. So I've done questions 1, 3, 5 and 9 with you, and I'd like you to have a go at doing as many of the rest as you can. If you want to do some of them today and then save some of them and do some of them in a week's time, then that might be quite a sensible idea too. But let me know how you've got on with that.